Greetings everyone, this is non-expert here back again with another video. Today we will be solving problem number 25 and difficulties when read that is hard. This problem was asked by Facebook, but I've seen it asked in Google interview and Amazon interviews as well. Alright, let's get down to it. So implement a regular expression matching with the following special characters. Basically these are the rules that if you have a period, it can match with any single character, and if you have an asterisk, it can match with 0 or more of the preceding element. That is, implement a function that takes in a string and a valid regular expression and returns whether or not the string matches the regular expression or not. If you don't know what regular expression is, you can Google it. But basically, what we've been asked is if you're given a regular expression like r, a, and period, and the string ray, you can see that these two guys are matching properly. And the reason why they're matching properly is because you can map r with r, a with a, and period with any character, which can be y, z, doesn't matter. And this function should return true. If we use the same regular expression on the string ray, mond, this should return a false because you map r with r, a with a, y with the period, but mond cannot be really you know um uh right. We can also look at another few examples. You can pause this video and have a look at it. We have a period, we have a star, and we have a t. This should also return a true value. uh it's pretty self-explanatory. Why? Because you can match all those things properly with each other, and you will not be able to match chats because s cannot be mapped properly, so that will return false. All right, cool. So fortunately we were able to find a problem which is pretty similar to this, and it's on lead code, so let's just cool. So you can pause this video and check out the link in the description below. I would sort of urge you to sort of go through this on your own, if you can. If you didn't understand what this problem is, it's basically a dynamic programming problem, and there are plenty of ways of solving this problem. Basically, what you could do is you could create a 2D matrix, and basically all the values from your left to right could be the string values, and all the values from top to bottom could be your pattern, and you could sort of just manipulate it accordingly. But there's a simpler way of sort of doing this, and we'll be trying to do that. Um, and the way we'll be doing it actually is by actually defining a set of rules, which we always do, right? Um, so let's actually define our rules. So if you encounter the previous thing, one of the important things is that if I have an I and a j value, which is basically the index, right, for s and p, or let's write this a little better. I is like index for string, and j is index for the pattern, right? What you could denote is that if you go to the previous example, right, like Raymond was not getting handled. Well, it was basically returning a false because MOND was not being followed through. The reason for that is just because you've passed through your entire J, or you've reached the end for J, but I is still not the same to the length. So basically, the first expression is that if J is equal to length of P, um, then I should also be equal to length of S, and only then is it a true value. This is pretty self-explanatory. If you didn't understand what this is, we're just saying that, hey, if I've traversed through my entire pattern, if I've iterated through my entire pattern, I should have iterated through my entire string as well. It's pretty obvious, and that's our first rule, and it's a pretty simplistic rule. And let's look at the other rules as well. So the other rules is that if we encounter a period, or if we have a set representation, right? Um, just to make it a little easier. Um, or rather, let's not do this. Let's do if I am at Si, uh, Si should actually be equal to Pj, or star should be equal to, or sorry, not star, period should be equal to, sorry, Pj. What we are saying is that if I have traversed, like for, let's take an example, let's take this example, right? If we have traversed through a B, our period symbol can actually be denoted as a. So if our pj sort of matches that, then only do we return a true, right? Um, that's also pretty obvious. And last thing is actually the wildcard entry rather, and the wildcard entry is actually pretty amazing because there are two cases which would happen here, that you have zero occurrences, or you have more than one, or just n number of occurrences. An example which can be denoted here is through this. You have C, then you have the star, and this is still true because the number of times C is repeated in our string is zero, right? Um, so the way we would be traversing it for that particular use case is pretty simple. The way we would be doing that is that if we have only zero number of things, then we just skip the pattern and we stay on the S value. So what we can say is that, hey, we need to increment J by 2, just skip these two guys and move on to the next pattern. And if we sort of go to N, if we have some occurrences like we have for A star B, because we have A and B, in that case, you stay on the same value of A, right? You still stay here, but you sort of stay, you sort of increment I. So in that case, you increment I plus 1. Whoops. Pretty self-explanatory, but I've explained these rules. If you didn't understand them, you can pause this video and try to go through these rules again. They're pretty simple, but yeah. So the way we'll be going with this entire approach is by creating an inner function, and it's going to be meme-wise solutions just so that we don't encounter any timeout errors. And throughout the process, I'll just explain how I do memorization also. Yeah. So basically, what we're going to do is we're going to have an inner function, and if you don't know what an inner function is, it's basically a function which calls inside another function, which can be called inside another function. Uh, and what we're going to be returning is dp value. Now, as you can understand, we were sort of talking in context of indexes and index of string and j index, which is of pattern. So basically, inside our dp, we're going to be assuming that we're going to have two values, which is going to be the number on which the index at which we are at for the string s, and the index which we are at for pattern, which is going to be. So we're going to do that, and we're going to basically start from 0, 0, which is pretty obvious because you want to start from the first element, and we're going to move forward from there. The expectations of this dp is basically going to be, it's going to return a boolean value no matter what, right? It has to. So yeah, and the way we'll be doing, and we'll sort of get into the nitty-gritty details of these things in a while. But let's go through the memoization first. And I'm going through it first is just because you can sort of understand how I sort of do it. So you know that it's going to be a boolean value no matter what. So you can sort of make a temp value, make it false, make it whatever you want to. And basically what you can say that if I comma j is not in memo, you do some iterations, and at the very end what you want to do is you do, actually let's remove the pause, you will store the value inside temp. So basically when those iterations are done, at the very end you will say memo ij temp, you know and basically you will return that memo is answer at the very end. Pretty simple. All you're checking is whether I, j is inside your memory solution or not. If it is, cool. Just return it. Otherwise, do some computation and update memo and just return that value. This is memorization. This is not the actual implementation. I will be getting into the actual implementation now. So we start with rule number one, which is basically like if we've already traversed through the entire pattern, then we need to make sure that all our string is also being traversed through. The way we'll be doing that is basically by saying, hey, if j of length, if j is equal to length of b, then, and do remember, we're not doing returns over here. Everything is going to, all the values that we've got are going to be stored inside temp. So temp is going to be equal to I equal to length of s. It's basically stating that, hey, have I iterated through my entire string or not, right? And this is rule number one. And if this is the case, then it will just go to memo, and then this will get returned. Pretty simple. Just remember that being used to return the entire value. So yeah, So that's the first case. The other cases are basically when we're doing all the other iterations, right? And the second iteration and the second thing which we sort of need to worry about is rule number two, which we've already defined, which is if Si is, or rather pattern J is equal to either Si or the period symbol, right? This particular rule is what I'm talking about. So the way we can do this is just by basically maintaining a variable is called first match. And we'll do a quick sanity check. Basically, I is less than S. This is just for safety. Um, and what I'm going to do is if PJ is in, I'll just make a dictionary out of this because it's going to be easier. You can do the or thing also. That's also possible. But I'm going to go with this. So all I'm checking over here is whether pattern J is equal to Si or it's equal to a period, right? Which is basically our rule number two. So we have handled that as well, right? And let's just handle this entire condition. So what happens if both of them, sorry, what happens if both of them are already equal? So let's say that if I am at, let's just take an example. Let's say our string was A and or rather it's AAB and this thing is A dot B, the pattern is A dot B. As you can see here, what we need to do is we just need to go to the next values, right? So we just need to do I plus 1 and J plus 1 and recursively call that. So that's what we'll be doing. Basically we'll be saying temp is equal to where the first match is there or not. If it's there, then also uh, if it's there, then call dp I plus 1 and J plus 1. Pretty self-explanatory. It's pretty easy to understand what we're doing here. We're just going to the next elements if it's a valid case. But before we do that, we sort of also have to worry about the wildcard entries. And the wildcard entries are a little bit more difficult to understand. So the way we would sort of do this is that we need to maintain the preceding value of the wildcard or the star. And the way we can do that is by just saying basically by checking J plus 1 itself. So we just say if J plus 1 is less than length of P, and this is just for a reducing number of index error calls. Um, if it's less than P and Pj plus 1 is a wildcard entry or star, whatever you want to call it, if it's this thing, then we need to make sure that we are handling these two conditions as well. So if that's the case, then we do temp, and temp is basically going to both these cases. So either you have zero occurrences or you have more than one occurrences. So what we'll do is we'll go with the first thing that there can be zero occurrences. So we'll do j plus 2, sorry, j plus 2, which basically states that we're not incrementing I, we're just incrementing j, just because there are no values are matching to that value. So let's say we have C star A star B has a pattern and AAB, so C is not there, so that's why we do J plus 1. So we handle that case over here, or we call that recursive call and it will get handled on its own. And the other thing is we check whether the first value is matching with the second value. So let's say that this guy is matching A star B is matching with AAB, because the first characters are matching right now. Then what we do is we just say, hey, these guys are matching, increment I and retain the J value, which we have already said. If there are n occurrences, then we do I plus 1 and that's it. We're doing an I plus 1 if it's a match. And just because it's going to be this or that, so we're just going to push our first match logic inside else. And it's pretty simple why we're doing that. It's just because either you have this or you have that, and that's just the entire approach that we're going to be using. So basically what we've done is that, hey, if we get from here to here, done. Otherwise, you do all those increments from there. So let's take a few examples, and to be honest with you, there's nothing more required because you've handled all the rules which we've already defined, and basically it's going to get recursively called over and over again till it sort of returns the value for dp00. Yeah, so let's write a few prints just to check out how our thing is working. Let's do for S and P, and first match true or not. Yeah. So let's just run this. Let's just look at our test case first. So our test case says you have a string AAA and you have a pattern A star. What's going to happen in that case is basically J plus 1 is going to be valid, right? So it's going to increment the values of I because it's following with this guy, where first match is also happening and DPI plus 1 and J is there, so I plus 1 is going to get incremented, right? So that's the increments I'm seeing here, 1, 2, and 3. And the moment that sort of happens, this first match value becomes false at 3 because it's gone through the entire notion. It's going from 0, 1, 2. When it reaches 3, we know for a fact that hey, it's reached 3. There's no more values in the string to process. As this says, hey, just it doesn't matter. It's a false value. Just return the value for dpij plus 2. So dpij plus 2 is going to get called now, and I is at 3, and j plus 2 is going to be 0 plus 2, which is basically going to come over here. And you can validate this entire hypothesis. It's on here. It doesn't really matter, but what's happening is it's going to come over here, and temp is going to get returned. So for all those values inside your stack, this is going to get returned as true, 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 true. And we're going to have temp over here, and then memo 0 of 0 is also going to be equal to true due to that. Basically, this is going to get popped out from here to here to here, and you basically have your solution. Cool. So that's it. You can check this out. You can also try to write this code in the same way I've written it. It's pretty simplistic. You can also look for other things like what happens if you have AAP, or what happens if you have ABCD, and you have C, and you have dot. Here this should also return true for us. Let's just check it out. Yep. And let's just try submitting this answer. Yeah. Cool. So you can see that it's faster than 97 of the Python online submissions, and memory wise, it's also pretty cool. So yeah, again, all we've done is we've just defined a set of rules and then we just implemented it using a recursive call. We're just recursively calling it over and over and over again. And it's pretty optimal as well. Again, if you don't understand this, you can leave it in the comments below. I'd love to explain it again. It's a pretty famous problem and it's pretty easy to solve also. There's not much here to it. Again, you can do this in a variety of ways. I believe that if you check online, you would find a bunch of solutions which have a 2D matrix and all. But I just feel like if you have a bunch of rules which you have already defined, you can sort of recursively call your function and just implement those rules, and it will just run perfectly for you. Cool, so that's it for today's video. It was a pretty long video because I was getting into the nitty-gritty details of all the implementation. But I hope you liked this video, and if you did like this video, do give a like and do subscribe to. We are a discussion over here, and we would love to have you. We're pushing videos on the daily, so yeah, it'll be awesome if you're with us. Again, if you've already subscribed, you're awesome. We all know it, and have a great day. Thank you.